So you all know that in transaction management, we go for concurrent execution of the transactions, right? So the idea behind concurrent execution of a transaction is that you are going to increase the throughput, the number of transactions that are being executed in a unit time, right? Again, uh, right, to make efficient usage of resources, right? So you have initially, if you are going to execute the transactions sequentially, you have CPU idle time and IO devices idle time and so on. So CPU, if a transaction contains some CPU activity and IO activity, it can be performed concurrently, right? So to make efficient usage of available resources, we go for concurrent execution of the transactions. And finally, to avoid short transactions, waiting for the long transactions to complete, we go for this concurrent execution of this transaction, right? So in today's class, in concurrent execution of the transactions, we'll study about log-based protocol, right? So one way to ensure isolation in concurrent execution of a transaction is that data items may be accessed in a mutually exclusive manner. So mutually exclusive manner in the sense that one transaction is accessing a data item, no other transaction can modify the data item. So the common method that is used to implement this requirement is that to allow a transaction to access a data item only if it is being currently holding a lock on the particular data item, right? So we have two types of locks in log-based protocol, right? So the last class also we discussed something about log-based protocols. Either we have to enter the lock on the complete database whenever a transaction starts with the execution of the particular whenever you start with the execution of a transaction, the transaction acquires a complete lock on the database, and it releases the lock only when the transaction is being completed and so on. So then we had some other version like instead of locking the entire database, you are going to lock only on the data item that is being needed by a transaction. And this is the other version of log-based protocol. Here we have two types of locks, namely shared lock and exclusive mode lock, right? So two types of locks are there in this log-based protocol. So if a transaction acquires a shared mode lock on a particular data item, it can perform only read operation on the particular data item. It's known as shared mode lock. We also have an exclusive mode lock where a particular transaction acquires an exclusive mode lock on a particular data item, can perform both read operation and write operation on that particular data item. So it's known as exclusive mode lock, right? So this is how we define or we describe the two types of locks, shared mode lock and exclusive mode lock. So in the case of shared mode lock, if a transaction TI has obtained a shared mode lock denoted by S on data item capital Q, then TI can only perform read operation on the particular data item Q. It cannot perform a write operation on data item capital Q, right? So whereas in the case of exclusive mode lock, if a transaction TI has obtained an exclusive mode lock denoted by X on data item capital Q, then the transaction TI can perform both read and write operation on data item capital Q, right? So this is the variant of lock based protocol where we are going to have two types of locks, namely shared mode lock and exclusive mode lock. So as given in the case of shared mode lock, whenever a transaction TI acquires a shared mode lock on a particular data item capital Q, it can perform only read operation on a data item capital Q. Whereas whenever a transaction acquires an exclusive mode lock on a particular data item capital Q, it can perform both a read operation and write operation on data item capital Q. Right. So we also have a lock compatibility matrix. So we can define a compatibility function as follows. So let A and B, they define, they represent the different arbitrary lock modes. And suppose that a transaction TI requests a lock mode A on item on which transaction TJ currently holds a lock of mode B, right? So TI is holding a lock mode, maybe a shared mode lock, and TJ is requesting a lock mode, maybe shared mode lock on the same data item, right? So if a transaction TI can be granted a lock on Q immediately, in spite of the presence of the mode B lock, then we say that A is compatible with mode B, right? So for example, if there exists only compatibility when both the transactions they want to perform shared mode lock on the same data item, right? Whereas if one transaction is holding a shared mode lock on a data item and other transaction wants an exclusive mode lock on a particular data item, capital Q, it will not be granted. And similarly, if one transaction holds an exclusive mode lock on a particular data item, capital Q, and another transaction requests either a shared mode lock on the data item, capital Q, or an exclusive mode lock on the particular data item Q, it will not be granted until the first transaction runs to its completion, right? So if you look into this transaction lock compatibility matrix, only if both the transactions they want to perform a shared mode lock on a particular data item, capital Q, it is permitted. Else it is not permitted. The other transaction has to wait till the first transaction has to complete.